Dear student, let us begin the lectures on machine design part 1. This is lecture number 23 and the topic is design of welded joints. This will be the first part of the topic. Now, if you remember, welded joint is a part of the joints which is normally known as permanent fasteners. Let us look at the different other types of permanent fasteners. So, this is the slide which was shown previously in the last lecture. Now, I want to repeat that again. The permanent fasteners have two types. They are of two types. One is the components which are held by mechanical force and there are two kinds. One is the riveted joints which we had discussed earlier, and the second one is the press fitted or interference fitted joints. The other type is that where the components are held by the molecular force. Now, these are the binding force which is responsible for the joint participations. There are three types, three or four types. One is welded joints, which will be discussed today and in the next class. Then there may be bracing and solder joint, and there are glued joints. Now, there are very large structures, for example, the great suspension bridge at Howrah, or maybe the Eiffel Tower in Paris, which is made of the parts which are connected by riveted joints. But in spite of all that, riveted joints are now losing their ground in favor of welded joints. So, normally today most of the machine parts are joined by welding. So, there are various reasons for that. Let us come to those reasons one by one. Now, let us look at the advantages of welded joints. Here, the first advantage is that high joint efficiency. Now, we must remember what is meant by the term efficiency. Now, efficiency of a joint is defined as, suppose that a single member, it carries a load P, and with the joint, suppose now we introduce some joint here. Now, with the joint, the load is carried, let us say P j. Now, definitely P j is lesser than equal to P, and P j by P, this is known as the efficiency of the joint. Now, how efficiency is important? You see that the efficiency is more means that the load carrying capacity of the member is more. So, ideally the efficiency should be 1, but in many joints, various joints, the efficiency are quite small, whereas in welded joint the efficiency could be reached very high, even 100% efficiency is possible. Now, how does efficiency help in design? That is, if we design, for example, we want to design the dimension of a rod which is subjected to uniaxial force P. Now, if we know the strength, then we can design the area of cross section as P divided by the sigma allowable. Now, with the efficiency, of course, the load carrying capacity is not P, but something less. So, therefore, in order to carry the same load P, the area has to be increased by some amount. So, the new area with the joint will be equal to A divided by efficiency. So, therefore, with small efficiency, we have a large area of cross sections required, and with large area of cross section, of course, what is increased is the cost or the weight of the structure. As I said, the welding is a process where maximum efficiency could be reached, because the weldings are nowadays very much standardized and we can join almost any metal to any metal. Even the plastics are joined by welding process. So, weldings are very standard process, and we have reached such a level that 100% efficiency is possible. Therefore, the welding process is very, very important and very, very useful in designing a joint. The second part is the the second one is the lighter weight. As I said that the efficiency, if decreased, that is efficiency low, will lead to larger, the heavier weight of the joint. In welding, the joint weight is very light. Why? The reason is that efficiency is high, and the second is that in some other joint technique, for example in a rivet joint, we use various other accessory components. For example, in rivet, when we want to join structural members, we use what is known as gusset plate. Now, gusset plates are used to join various members. So, these are the parts which are to be joined. Now, there are rivets there. So, therefore, this is additional component which is required, this gusset plate. Similarly, in bolted joint, we need the nuts and the washers, etc., and maybe the locking devices of the nuts, all these things. Also in rivets, we need cover plate sometimes if we use butt joint with single cover or double cover. All this will lead to the heavier weight of the joint. Now, in welding, of course, the weight is lighter. Then the third point is that smooth appearance, because the welded joints could be given a machine finish, maybe by grinding or by some machining, sorry, chipping operations. So, therefore, the joint appears to be very smooth. In modern fancy cars or in automobiles, various types of welded joints are used. The fourth point is ease in alteration and additions. Now, suppose after making a joint, we want to alter the joint to some extent, or we add some joint again to the structures, then of course, this process becomes very easy with the welding joints. Fifth is it is less expensive. It is very important to have low expense in joining. The other joining process is they are quite expensive because of the accessories used, or maybe the joining technique. Then it takes more time. Also, it requires some other process. For example, you might have heard the name die plate in connection with the joining of two parts by rivet joints. So, these are all the things required there, whereas here we do not need much. So, therefore, this is less expensive process. And then ease in joining, the final point, ease in joining at difficult locations. Now, this is also quite important, because in joining, say by rivet process, we need to hold the rivet head and then apply force to the tail of the rivet. Now, that requires some clearance to make a riveting. Also, in the bolted joints, we need to have some clearance for the fixation of the nuts. Now, here less clearance is required for the welding joints. Now, in some cases where the reachability of the operator is very difficult for the other kinds of processes, in welding joints it is very much easy. Now, in modern world we have various automated welding process, therefore, the expense is small, and then we can have enough flexibility in the welding process, therefore, the ease in joining at difficult locations is there. So, these are the different advantages of welded joints, and therefore, these welded joints are used almost extensively in today's engineering world. Now, let us look at the typical welded machine components. Here again we have pressure vessels, steel structures. Now, normally pressure, as I told in the last class, the pressure vessels are sometimes joined by rivets. Nowadays the rivets are being replaced by welding, because the welding techniques, different sophisticated welding techniques have been developed, and researches are going on in the welding technology. So, therefore, all this has led to the increased strength in joint. So, therefore, pressure vessels are joined more or less usually in the industry. the steel structures, for example, the columns or beams or plates, are joined by welding. Then flanges, welded to shafts and axles. One kind of flanges you have already come across, for example, the flange coupling. There are different other types of flanges used. Now, mostly all the flanges are connected to the shaft or axles by welding. Then crankshaft. Crankshaft is a curious looking or a very complicated looking member, but this is made of simple parts by joining them by welding. So, the crankshaft is made by welding. Then heavy hydraulic turbine shaft. When we have heavy hydraulic turbine which is used to generate very large power, so then the turbine shaft is made of two parts and they are split in two halves, and those two halves are joined by welding. Then large gears, pulleys, flywheels, etc. Now, gears, pulleys, flywheels, when they are large inside, they are made of several parts. One is the gear hub or pulley hub or flywheels hub, which is relatively thick in cross section. Then we have, of course, what is known as a rim, which is the outer periphery of the large gears or pulleys or flywheels, and the connection between hub and rims, which is normally done by spokes or various connecting rods. Now, these three components are made separately and they are joined by welding processes to make a complete machine element. Then we have gear housing. Now, gear housing, when the reducing gear train, the gear housing box is made by joining different steel plates, except of course few cases like the bosses for the bearings. Mostly the weldings are used. Then machine frames and bases. The machine frames and bases, they are made by joining various structural members like beams and plates, which are made of generally of steel. Again, housing and mill stands. So, in a large mill operations, we have the mill stands which is manufactured in parts, and they are joined by means of welding joints. So, these are the typical examples of welding. Of course, this is not exhaustive, and various other components are made by welding process. It is so much useful that even although this welding does not belong to a manufacturing process, but it is named one of the manufacturing process because modern day manufacturing involves lots of welding. So, this is very, very important in designing. Now, we come to the point. Now, what are the basic types of weldings? Now, we have to look at the basic types of welding process. Now, welding process can be divided broadly into two classes. One is liquid state welding, or what is known as fusion welding, and another is the solid state welding. Now, there are various kinds of liquid state welding or fusion welding. One is the electric welding, that is fusion. What happens is that one of the material or the parts which are to be joined are brought to molten state, to liquid state, and then of course some metals or non-metals are added to increase the strength of the joint. Now, depending upon the source of the heat, the process could be differentiated into this following kind. If the source of heat is electricity, then this is the electric fusions welding. Now, there are few welding processes under the same heading. One is the arc welding. Now, this is very, very important welding process, and most of the weldings nowadays are arc welding process. Here what happens, now suppose we want to join two metals. Here two metals are to be joined. Now, here this part, that is this part has to be melted first. This part is melted. Now, how this is done? We use one arc. We bring one electrode. So, this is electrode. and we momentarily touch the electrode to the workpiece and then take it away. That produces, because of high voltage, that produces arcs, and these arcs are sustained by various techniques, by giving a coating to the electrode, or by selecting proper electrode materials, etc. So a sustained arc is created, and that gives enough heat to this workpiece and it melts. Okay, and when it melts, then the liquid can be, well, the liquid metal mixes in this region and a solid joint is formed. If you look the entire thing from this side, then the structure looks something like this. So this is the metal looked from side, this is another part of the metal. Okay. Now we have electrode here, we bring electrode, and then because of this high voltage, this arc is generated, and because of the high pressure, then a crater is formed, which is known as arc crater. Here, of course, the molten metal gets deposited, right. This is the weld metal, and on top of it there exists another layer which is made of slag. So this is the part which is known as slag. Now after the welding is finished, then this slag is removed by various process like chipping or grinding, etc., etc. Here, of course, the main important thing is this generation of arc. Now this arc, as I said, these are generated by means of various electrode. There are various processes. One is the bare electrode arc machining. Here, of course, we have to shield this arc by in some gaseous atmosphere. Why that is important? Because in the molten state, the oxygen may be entrapped, and that may oxidize the material, and therefore it leads to brittleness. So therefore this oxidation has to be prevented, and this is done by making this welding in inert atmosphere. So this inert gas is given by shielding this in a casing, and inert gas is given. Mainly the argon gas is applied. Now depending upon the nature of the electrode, they may be of different types. One is tungsten electrode, that is which is called TIG welding, tungsten inert gas welding. Sometimes, but here the tungsten is not consumed. We have metal inert gas welding, MIG welding, where of course metal is consumable, that is consumable metal inert gas welding. Then we have another technique where we do not use this atmosphere, this inert gas atmosphere, but what we use is shield this electrode. Now this shielding is done so here we give another coating to the electrode. Now there are various techniques of coating, and this gives the shielding. Now there are various shield materials, for example rutile or cellulose based. Titanium oxide is given, or sometimes of course we have the hydrogen or base material such that the oxidations could be avoided, but with hydrogen assisted it becomes that hydrogen gets embedded in the or entrapped in the molten metal, and that leads to embrittlement. So this is hydrogen assisted cracking or embrittlement is a severe phenomena which should be more or less avoid. So, therefore, we do not normally use the basic the hydrogen rich material as the coating. So, there are various kinds of coatings available. So, this is roughly what is known as the arc welding. Now, we come to another type which is known as the resistance welding. Now, resistance welding, here the principle is that when we make two metals in contact, then even if the contact area is very large, but only a small portion gets practically in contact because of the asperities or unevenness in the surface. Now, this small area in contact, when a large current is passed, large current is applied, then therefore, the high resistance is developed here, and this large resistance, even if you should not forget that there are always oxide layers present. So, there are impurities here. So, therefore, resistance is appreciable, and because of the large resistance, the heat generated, which is given by I square R T. So, heat generated will be quite high, and that melts this part, okay, and then they get joined. So, there are two kinds of resistance welding. One is known as the spot welding, where spot welding is here two metal. Suppose this is one metal part and another metal part is here. These are to be joined. Now, we put it under two copper electrodes. So, these are the copper electrodes and the current is passed. Okay. So, current is passed and therefore, welding takes place here. Well, so this is the spot welding. Now, we have seam welding, which is just a running version of the spot welding, and there what happens, we have the electrodes in the form of two rollers. Suppose we want to add, this is one metal and another metal. Now, we pass it between two rollers. Now, these rollers are made of copper. So, this is copper roller and a large current passes. So, then we move the whole things together. Okay. So, which velocity v is given, and therefore, when it moves, then we see a line of welding, and this is known as the seam welding. Then we have another kind, which is okay. This is about the resistance welding. Then the another type is induction welding, of course, which is very useful. Then second comes, which is very important, which is chemical welding. Here the heat is generated by chemical reactions. First one is the gas welding, where of course, this is the metal, the cross section of the joint, and then a gas torch is brought here. So, this is connected to acetylene, oxyacetylene, okay, and a gas burns. So, that gives high temperature here, and this melts. Filler rod is added, filler material is added somewhere there externally. So, this is filler material. So, when the liquid melts, then because of this heat, the filler material gets also melt and is added to this structure. So, a high strength bond is formed. In the thermite welding process, of course, this is not very much used, but it is used only in the field welding. For example, in the rails, when we want to weld inside, then we use the thermite welding. Here the process is that the heat is generated by chemical reactions. Alumina when added to ferric oxide will give iron, and so this is the reaction. Now, that is a very exothermic reaction. So, heat is generated and that heat melts the base metal. Now, here what we see, this iron is added. Now, iron is not enough, we will have to add some materials because we want the steel, and in the iron carbon diagram we have to add in order to make steel some amount of carbon and some other alloying elements, because this is very important to use alloying elements. So, normally along with this powder we use other flux materials. So, this is known as thermite welding process. There are other advanced welding techniques like electron beam welding or laser welding. Let us discuss the electron beam welding. Here electron beam is generated and then this electron beam is focused to the metal. Okay, so this is the base metal, this is electron beam, and a very focused, very large temperature, large heat is generated, large temperature is maintained here, but within a small area. But here the disadvantage is that it needs very low pressure, very low, very low pressure, that is it needs almost vacuum. So, we need a very low pressure, but this disadvantage could be avoided if we use laser welding. Now, in laser welding we have to focus the lasing material, the laser. Now, nowadays we have different kinds of laser, and this is very useful nowadays, and lots of researches are going on in this field. But here one improvement is that a large heat is generated over a small area, and but here the heat is concentrated, that is the heat loss is less. So, therefore, many other complications because of this heat loss can be avoided in laser welding. Then there are other types, which is solid state welding. Sorry. Here, of course, in the solid state welding we have we do not fuse the metal into liquid state, but we use the pressure in order to deform the materials into plastic state, and then by pressure and various other techniques, then these two metals gets joined. Now, from today's point of view, the most important is this electric arc welding or resistance welding, and also chemical welding and laser welding, of course, to some extent. Now, let us come to the design part. Here, of course, we have the types of welded joints. Now, we have few types. One is the lap or fillet joints. Now, here the structure looks like fillet joints. Suppose we want to join two metals. And this is one metal which is to be joined to other metal. Now, here two possibilities are there. One is that we could apply welding in this side and in that side. So, if you look from the side, it looks like So, if you look from this side, then we have welding this way. So, therefore, this is known as parallel fillet welding, parallel fillet joint. Now, always with the welding we have different symbols. The symbol of fillet joint is this. This is the symbol associated with the fillet joint. This is the symbol. Then of course, we could have used the welding in different manner. We could have used the weld metal here. Then of course, if you look from the side, it looks there is one metal and there is another. Now, here welding is applied here. So, this part is welded. Of course, the force is given in this direction, force in that direction. So, of course, the joint has to carry some load. So, load is acted here. So, this is known as the transverse fillet joint. Now, definitely there is only one fillet. So, this is known as the single transverse fillet joint. There may be also double fillet joint. If you apply another fillet here, then this is double fillet joint. And of course, the symbol as usual is this. Then we come to the next type, which is known as the butt joint. Here we want to join two pieces side by side. These are the two components and we want to join side by side. This is butt joint. Then sometimes we have to prepare the face of this butt. It may not be straight always. So, there are various possibilities. If this is straight, then this is known as square joint. So, then when you add welded metal here, then the joint looks like so. This is known as square butt joint. Of course, here the symbol is this is the symbol of a square butt joint. Sometimes we use single V. The next type is single V. Let me draw. Here we use a single V joint here. So, as a V is formed by cutting this sides of this and then we apply weld. So, therefore, the weld looks like this and the symbol here is so this is the symbol of the single V butt joint. We have double V joint, which looks like the following. Here we cut this is the face and similarly we make other face just like that and then we apply weld metal. Here of course, the welding is done here and so this is known as the double V butt joint and the symbol here is of course This is the symbol of double V bar joint. Then we have single, so this was double V, then we have single U joint. How does it look like? We have one is kept straight and another one is here. So, this is a groove is formed here and then we apply weld material. So, here this is the single U joint. One small correction, this is known as single J joint rather, not single U. So, this is single J joint because it looks like a J and the symbol here is, so this is single J joint. Similarly, we have double J joint which looks like just very similar. A double J joint will be again straight and here and there. So, again this type, then the filler material is given here and then the symbol looks like double J. We have single U, now we have to discuss the single U joint. Single U joint is both of they are kept here and then molted metal is added. So, this is single U and this is this. We have double U if we have this kind, that is the grooves are cut in both the on both sides and we have the symbol. So, this is single U, that is double U. Then we have single bevel joint. We have single bevel joint. One is kept straight, another this way and then weld material is added. So, this is single bevel joint and the symbol is like this. We have double bevel joint, very similar. This side as it is and here, and we add metal on this. So, this is double bevel joint and the symbol is something like this. So, these are roughly the bar type joints. Then we have another kind which is the edge joint. Now, here the two metals, the edges of the two jointed components are brought together and then the welded material is added. So, this is the edge joint and the symbol is this. We have T joint. We have T joint, here one base metal, another metal is added. So, this is to be jointed in form of a T. We apply over here. So, this is the T joint. Now, you see that the fillets are used here to make a T joint. We have also corner joint, which again looks. So, this is one metal which is to be now joined to other, and we apply weld here. So, this is the corner joint. So, these are roughly the types of welded joints. Now, we have to know the standard locations of welding symbol. That is very important, because if you are going to design, then you will have to be you will have to have some understanding or some informations about the knowledge about the drawing of the machine components. Here you see the welding. Suppose you want to designate the welding, then it is given by means of a reference line and one arrow here. So, this arrow points to the place, to the joint where the welding has to be applied. So, this is the arrow, and here the first is that if you want to describe the welding process, then there is a tail of the arrow and you write down all the process descriptions, etc. Sometimes if you do not want to describe this, then you may omit this, that is, it is possible to not to give this one. Then the important thing is that you will have to give the welding symbol, that is, what kind of welding is to be given. So, here there are two sides. So, if you specify the welding type in the bottom part, bottom of this reference line. So, this is the reference line. So, if you mention the welding symbols, for example, this is the welding symbol of a fillet joint. So, that means that this fillet type welding has to be used in the arrow side of the joint. Now, if you use, so this is this side, that is the to the arrow side of the joint, this this kind of welding has to be applied. So, if you want to apply on the reverse side of it, then you will have to give welding symbol. Maybe you may use two different kinds of welding, but proper symbols are to be given. So, this gives on the other side of the arrow. So, this is the top one is the welding on the other side of the arrow of the joint pointed by this arrow. Now, this together, both of them together, means that both sides are to be joined. Then we have to specify the size. Here we specify the size of the joint. Now, normally in the fillet joint, you might have said there are two possibilities. One is that this length and that length. So, these two lengths may be, since this is 45-degree angle, so they are equal normally. So, one is enough, one size is enough. This is the height, the fillet. So, this size has to be specified. Then here we give another specifications, that is we specify here, of course, the length of the welded and the unwelded parts. There may be cases where the intermittent welding is given. So, we have to specify exactly how much of how much part will be welded and how much will be left unwelded. So, this all informations are to be provided here. After welding is done, then we have to give the contour to the weld. For example, here these are the two parts. Now, here the contour is straight contour. Sometimes by machining operations we have this kind of contour. Suppose we want to give this contour. So, this contour symbol has to be given. Now, here the contour symbol is here given like this. So, here of course, the contour symbol is given. Here this part will have this one, or sometimes concave contour is given. So, this is the contour is given. Then we have to have the machining, the finish operations. Here the machining has to be done. Now you have to write the symbol M for machining, G for grinding, etc. So if you write this, then it means that a surface to be convex shaped and then it is to be ground. So all these informations are given in a welding symbol. Just an example, and of course there is another thing. Here we have this kind, a symbol that is weld throughout, that is weld all around, and if instead it is given this is called the field weld. So this is the symbol which is called weld all around, and this one is the field weld. So these are the symbols used for the welding. Now let us look. Let us look at example. Suppose we have two parts which are welded this way. Now if the arrow pointed that way, that is, this is the point. So if you want to use this weld, then what we have to do, we will have to write the proper welding symbol both sides. Let us say 5 millimeter. If the 5 millimeter is this height, then 5 and 5, and then it is to be machine finished. Machine finished. It's a straight edge. So all this information, all the informations are given, and maybe you can apply the length. Suppose you want to weld around a circular member, then of course if we have this section circular, then of course you may use this symbol, such that means that all around this there will be the welding. Okay. So these are the weld types or welding symbols which you must know. Now we come to the very important point as far as design is concerned. We want to know the strength of welded joints. Now the welded joints, they are very difficult to analyze in terms of stress. So what we have, we use the strain data by means of some experiment. But first of all, let us check what are the factors which affects the strength of a welded joint. One is the crack initiations. Now there are various possibilities of crack initiations. One is that if you look closely into the welding process, then you see that here, so this is the metal, now welding is applied there, weld material is applied there. So here there is a zone which is in liquid state, right, and this part, so this is the melted portion of this metal. Then there may be a part, that is this part, which is adjacent, which is not milled, but which is affected by the heat applied at in this position, that is in the main heat source. So this is called heat affected zone. Normally has. This is very important because here lots of complications occur. The metallurgical transformation takes place in this in these locations. So this heat affected zone and this is non heat affected zone, that is the original metal. This is the original part and this is welded part or maybe melted. So whenever it starts cooling, then what happens, the cooling procedure is very much like in a casting. So all the defects of castings are present. So when it starts cooling, then the procedure becomes very interesting. That is, you see that whenever it cools, then after cooling this kind of grains are formed, and when the solidification has ended, then there may be a place where a crack is formed. So, this is the part where crack is formed. So, this is due to the solidifications. There may be other causes of crack. For example, in this heat affected zone the crack may initiate. Then of course, so these are the typical crack initiation process. We have then the we have then the residual stress. The residual stress here, you see, this is due to the uneven heating of the metals. So, the residual stress will be developed because of the uneven heating of the metals, and whenever there is uneven heating, so there will be a thermal stress developed. You know that epsilon is proportional to delta T. So, whenever there is a change in temperature, there will be a strain, and because of strain there will be stress developed, and this stress causes the may be so high that crack may be developed. So, this residual stress is also very dangerous. Then the metallurgical transformations. Here, as I said, that in the heat affecting zone the metallurgical transformations may take place. Normally, because in order to have a high strength we have small grains, but because of the heating the grain size gets increased. So, therefore, the strength in this region gets down because of the heating. So, the grains are coarsened and that leads to low strength. The ductility is of course increased, but that is what we do not want. Then there may be various defects possible. One is incomplete penetration. That is very clear that whenever we have incomplete penetrations, for example, in a butt joint we want to have the joint, but the incomplete penetration takes place. So, it forms a sharp notch, and that is a place where the stress concentration develops and the strength gets weakened. Porosity may be there. So, these are the defects. Slag inclusions, these are the defects which adds to the lowering of the strength. Then stress concentrations, now that may be due to the geometry of the weld, and that we discuss in the next class when we study the design proper. But now let us see. So, this is about the strength of the welded joint. Now, this was as far as today's lecture. Now, let us come to the homework problem which was given in the last class. A double riveted lap joint was zigzag and 30 millimeter thick plate. So, 30 millimeter thick. Now, Unwin's formula if you use, then it gives root 6 root T millimeter, and this is the diameter. Now, with the diameter we use the strength. Now, the strength is P minus D times the thickness times the tensile strength, and this is the tearing strength. Now, we have to use the shear of this plate. So, that shearing is done again. You see pi by 4 d square. There are 2 because there is a it's a double riveted. So, this times the shearing stress. So, these are the allowable load in tension in the shear. Now, if you equate this, normally they are equated. So, if you equate this, you get the P, and then once this P is known, then the diametric transverse pitch is also calculated by this formula. The transverse pitch will be equal to the diametrical pitch is calculated by P plus twice D by 3. This you will find in handbook. Then of course, when the design is completed, you will have to get the efficiency. Here you will have to calculate first the crushing strength, the shearing strength and the tearing strength. Now, the crushing strength is calculated if you use the proper cross sections, that is the pi d of this rivet times the T times this crushing. So, this gives the crushing load. Now, you have to calculate the minimum of this PC, PT and PS and divided by the original load without any joint, which is equal to P times, that is the pitch, times D times the sigma T. And if you calculate, what you get is that efficiency turns out to be 67.5%. Okay. So, this is the result. Now, that was the homework problem. We will discuss again the welded joints in the next class. Thank you. Dear student, let us begin the lectures on machine design part 1. This is lecture number 24 and the topic is design of welded joints, and this is the concluding part of the lecture on the same topic. Let us recapitulate a little bit what we had learned in the last class. We talked about different kinds of the welded joints, different types of welding processes, and towards the end we mentioned about the strength or the factors affecting the strength of these joints. Now, let us begin from the same place where we had ended in the last class. So, this was the strength of welded joints we are talking of. Now, the strength of welded joint gets affected by, there are few criteria, few things which affect the strength of the welded joint. One is the crack initiation. Now, we mentioned that there are few causes of crack initiations, that may be due to the solidification contractions. Then there may be the cracks in the heat affected zone. Then there may be cracks due to the residual stress or incomplete penetrations, etc. So, there are various reasons for crack initiations. Then we talked of the residual stress. Now, because of the inhomogeneous or non-uniform heating of the weldment, that is the parts which are to be joined by welding, because of